Hello and welcome to my talk, What's in the News or Why Angela Merkel is Not Significant. My name is Andrej Rosenheinrich. What I'm going to talk about today is some work I've done and some experiences I've made together with a colleague of mine, Dr. Bernd Eickmann, who is mainly responsible for the natural language processing part of this project, but more about that later. We both work at the Research and Development Center at the department of the Unister GmbH in Leipzig. In case you haven't heard about Unister, it's not uncommon. Unister is one of the biggest internet companies in Germany. You certainly have heard of some of our brands, with brands like abininurlaub.de or reisen.de. We are market leader in online travel sales in Germany. We're one of the main contenders in areas like online flight ticket sales, hotel reservations. But apart from the travel area, we're also running a lot of pages in areas like finance, like shopping, like comparison. So if that's interesting for you, go check the website unister.de, and usually there are some jobs around at locations all over Germany. So at the Research and Development Department, we do something slightly different. Our main focus is development of bluekiwi.de. Bluekiwi is a meta search. Okay, why another meta search is a question I get asked from time to time, and whatever this laptop is doing here. Why not a meta search? Well, doing a search is not that difficult today. Set up a simple full-text search or whatever is something you can do. There are tools around for that. It's ready out of the box. If you have the data to search on, it's always one thing you have to keep in mind. What is the difference between a search and a good search? It's of course the relevance of your results, and everyone is doing some certain things to improve the relevance, and two of the main ideas we're doing, what are not so uncommon, I guess, is of course a semantic analysis of the search query. For instance, here in this case, the query would be Gulf Mexico, and we would think that you probably talk about the Sea Gulf of Mexico and present you the certain results, like the fact box in the upper right corner for that, and so on. If I would query for Gulf in Mexico, even that in is a stop word that would not be considered in a full-text search. The semantic analysis tells you, okay, this is something different. Maybe we're talking about Mexico and the sport golf in Mexico. And so semantic analysis helps for sure. Another thing that we're doing is we're considering the context, or the context is actually something that we do not know most of the time, but context is something that would bring a different result. When I'm looking for Mexico, what am I looking for? Am I looking for facts? Do I want to go there for vacation? Maybe I need a hotel, and so on. And so we implemented a lot of different searches in a different context, and depending on what we think is the important context for the query you use, we display certain boxes with such a context, and you as the user can decide what you actually want to see. You want to see the hotel offers or the facts or the news or whatever. And as I mentioned, one of the context modes we wanted to have is news search. And probably a question I do not have to plot out that much, but why do we want to have a news search? News are a topic of amazing interest. If you look at the Alexa ranking of the most visited pages in Germany, in the top 25, there are at least 5 news or news similar. We can argue about 1 or 2 of them. Pages that I would consider as being news or news similar. Think even further, there are domains like t-online.de, like gmx.de, that contain a lot of news, so news seems to be of a huge interest. And the other thing about news is there's a lot of it around, a lot of sources you can think of, a lot of news, and let's face it, a lot of something you can easily lose overview is the perfect scenario for a search, right? So it was a no-brainer. We wanted to do news search, we wanted to have it, and we did what we had to do. We set up a process to fetch news from many, many sources constantly. We do some pre-processing on the news. We store the news in an index. What is cool, so we can use all the fancy features of Elasticsearch. And with that data we got, we implemented a search on it. Our designers came up with a screen, front-end team put it on the page, and voila, there we go. We have a news search, we have a news box. It looks good for us. The results are good. Users like it, we like it, everyone's happy. But as usual, you have a huge amount of data laying around, and for sure you start thinking about what can we do with that data if it's interesting. And with a lot of news, actually it's pretty obvious what you can do or what you would like to do. What we would like to do is aggregate news. Imagine there are more than 100 newspapers in Germany. Every newspaper is writing about how the last soccer game actually went. The result is the same everywhere. You don't have to display it 100 times, just show the fact. This is the result, 1-0 or whatever. Maybe you don't want to read all the news, because just too many of them. I want a short summary, a punchline. You know, this is the fact. We won the game. And of course, and that is part of the title, we want to figure out what are the important news. If I have a 5-digit number of news every day, I cannot read all of them. I want to focus on, let's say, the top 10 news. So we actually know what we want, aggregate, summarize, find the most important news. That was the task at hand. The only thing we did not know is how to get there. So let's start with the last thing here is how can we figure out what are actually important news. I'm quite sure that I'm not the only one who encountered the task of figuring out what is the important part in the data I have. And I'm quite sure that probably almost everyone knows that counting is usually not a solution. Whatever you can count terms, you can count entities or whatever you got. But still everyone is trying that. I tried it too, it's not working, we need something different. So what is an idea to figure out what news are important? I had an idea in mind, and I guess you can already guess what it is because it's in the title. It's Elasticsearch's significant term aggregation that was introduced, I think, at the beginning of last year. And in case you haven't attended the talk about the significant term aggregation yesterday, or you never heard of it, what is Elasticsearch significant term aggregation about? You can read up a blog post. There's a very good blog post about it. Or you read the definitive guide. That's worth reading anyway. And the definitive guide actually explains it the following way. The significant terms aggregation finds uncommonly common terms in your data set. What do we mean by uncommonly common? These are terms that are statistically unusual. A hell of a definition, but what does it mean? Actually, we compared two sets of documents. One is the foreground set, that is the set of documents you select by a query or however, and you have a background set. Simplest case is the background set is your whole index. You could narrow that down by other filters or whatever. And then you compare how often do terms appear in this set of documents. And if this frequency is higher in the foreground set than it is in the background set, significantly higher, then something is happening, or this term has a special significance within your foreground set. If you imagine I have a term that is in my background set in every 50th document, and in my foreground set it's in every 3rd, so this seems to be really, really important for my foreground set. So this is the idea that we wanted to use. Choosing the foreground set is pretty simple. I could do a range query and say, like, give me the news of the last 24 hours, and then figure out, okay, what is important during that time. With this definition in mind, I can actually explain a part of my title as well, because I claimed that Angela Merkel is not significant. Why is Angela Merkel not significant? Well, obviously because she's in the news every day. There's a poor guy at a newspaper that has to fill a page every day, or thinking about what to write, and just writing down what Angela Merkel is doing is a safe bet. So her name will be at least 10 times in every newspaper every day. Think about an even more extreme example, weather forecast. If you take data from one newspaper, there will be one article with a weather forecast every day, and no one would be amazed that tomorrow will be one article with a weather forecast. So this is not significant at all. This is nothing we have to look at. So significant term aggregations is the idea we want to use. But there is a problem with significant terms aggregation, and that is, what are the terms you're looking at? We're using the headlines for significant term aggregation, and you could say, okay, I use the terms that are delivered by Elasticsearch, but the output of my analyzer. That will give you a single token, or maybe a bigram, whatever you put your index, set your index up. But the problem is, this usually is not really descriptive. Another problem is you would not consider grammar. You could come up with Merkel, but you also could come up with Merkels and so on. And the Merkel example, usually names will be split. As I said, the name thing you could do with bigrams. That will save you on Angela Merkel. It would not save you on Sabine Leuthersser-Schnarrenberger. But you could go ahead and say, okay, I have a bunch of bigrams. Maybe they're overlapping. Maybe I concatenate them and so on. I tried all this. It's really funny what results you will get. But still, the output will, in rare cases, be well-formed or make sense or so ever. So just working on simple terms is not going to bring you anywhere. I said we're doing pre-processing. One of the things we do in pre-processing is we do an entity recognition. We could use the entities of the news for a significant term. That is cool somehow, because what you will get are clean, valid results. You don't have to care about names. You have proper labels. Everything is cool. Still, it's not descriptive. You might know that Angela Merkel was somehow important yesterday by chance, but you do not know why. Another thing with entities is you will not find new news. If your entity recognition does not know the term you're talking about, a company introducing a new product, you will not realize that this is important, and not being able to detect something new in news is a mistake for sure. And last thing, and that is a problem for both of it, you cannot aggregate on this news. I said we want to aggregate, but if I know that I have the term Angela Merkel or the entity Angela Merkel, and it is contained in Angela Merkel meets François Hollande, as well as Angela Merkel meets Vladimir Putin. But you cannot aggregate on that because it's the same. It's a different news, and you have to figure out something different. So at least here we notice that we have a conceptual problem with the whole thing. We have to think about something different, and the solution here was pretty obvious. We have to move away from token being a term or an entity or just a single entity, whatever you want to call it, to effects. We have to consider the headline or the news in whole and try to make effect out of it. And that's where I was looking, sitting in my office with a sad face, a bit stuck here. My colleague came up to me, asked me what I'm actually trying to do and how the whole thing is working. And he said, maybe I can help you here on that with some natural language processing approach. And he came up with a 4-step process that he implemented as a prototype. I'll skip the steps here. I explain them in detail in a few moments. But just the idea is, what are we trying to achieve? We want to find the important terms that summarize the sentence or the headline based on the structure of the sentence. So how is it working? Input is, as I said, the headline. We do some basic NLP stuff. We do sentence splitting, remove some special characters that we don't want to consider. That just makes a few of the rules that we will see in a few moments easier. We do tokenizing. All that is basic standard. And in the end, we do a part of speech tagging. Everything can be done with out-of-the-box tools for speech tagging. We use the Stanford Post Tagger with the STTS tag set from Stuttgart. And the example, I guess everyone's seen something like this before. There was a talk from Grant Ingersoll yesterday. You have a sentence like, Angela Merkel trifft am Mittwoch Vladimir Putin in Moscow. Angela is a proper name, Merkel is a proper name, trifft is a finite verb, and so on. okay, nothing magic in here. Next step is a chunking step, or we also call it phrase detection. We have a set of rules, a regular grammar, and we apply this grammar to the tagged sentence and try to figure out actually what tokens together are could be combined to a phrase. For instance, I could say that a nominal phrase for me is a sequence of proper names, at least one, prepositional phrase, and so on. Take the example here, you come up with a representation of the phrases like in the bottom of the page. If you don't like this kind of representation, you're more into drawings, think of it as a syntax tree representation. I have a sentence, the sentence consists of a nominal phrase, a verbal phrase, a prepositional phrase, and so on. This is also nothing too magic. The only thing you have to come up is, what are my phrases, what is the set of grammar? That is something you have to implement on your own. Third step, we actually use these trees, probably partial trees, to extract facts. We have a self-implemented extraction language with the goal to extract important keywords by using a set of rules. For instance, we have a rules, we say, okay, we have a nominal phrase followed by a verbal phrase. If we have something like that, okay, that is a match, and from this match we want to keep certain parts, like we want to keep the nominal phrase, we want to keep the verbal phrase, but from the verbal phrase we actually keep the verb, the finite verb, and the nominal phrase at the end of it. So from our example, Angela Merkel trifft am Mittwoch Wladimir Putin in Moscow. What is left over as a fact by this rule is Angela Merkel trifft Wladimir Putin. We apply all the rules we have to the syntax tree. Potentially, we have a set of results. We have to filter out what is the best result for us. You can think of a lot of filters. Actually, we apply several of them. One possible filter could be just the length of the result you get. Merkel trifft Putin is even better. Maybe you prefer the longer form, Merkel trifft Putin in Moscow. Maybe you don't, because it's not the idea of summarizing. You want a really short summary. That is one filter you could come up with. Another idea would be coverage. What is the rule with the largest coverage of my syntax tree, and so on. Okay, we got those facts. And out of those facts, in the last step, we generate summaries. Actually, we do two things. We generate normalized terms out of it, and also we want to generate a syntactically well-formed summary, something we can present to the user as human readable result, as a potential search query he can use on our website to get to the actual news for that summary. The first thing, the normalized term, it's pretty simple. We take the keywords we extracted in the last step, we normalize them, we concatenate them, we put all this in an index. I actually thought I switched it off. Come on. So in our case, Angela Merkel trifft Wladimir Putin. The normalized concatenated form that we actually store in the index would be Merkel treffen Putin. And we also generate the well-formed summary. That is pretty simple. We take the syntax tree and we remove actually all the parts of the sentence or of the syntax tree that we do not want to keep with our rules. And from the example, the syntax tree that I showed here, what will be left over is, in the end, a summary: Angela Merkel trifft Wladimir Putin. What is human readable, what is descriptive, what is a good result that we can present to our user. So, what are we doing with that? I'm coming to the end. We can use the normalized summary for the significant term query. These are some examples that would show you what kind of normalized summary we would get out. GDR Ankündigung Streik. These are examples like 2 weeks ago, so just in case you recognize the news. And if we have something like this, we can easily look up what is the well-formed summary displayed to the user, and so on. So we think we accomplished our mission. So in the end, to summarize it, we found a way by using natural language processing to aggregate news, to summarize news, and also using Elasticsearch, we found out what are the significant news. We can display this to the user. This is an actual example from our website. There are, of course, some problems still there. It's an iterative process to actually get all those rules correct. There are always examples that don't work. And with that, actually, I'm done, and there's only one thing left for me, and that is, come on. It's on my laptop, by the way. And that is to actually invite you, come and see it at bluekiwi.de. This is not theory. We implemented it. It's live. Thank you for listening.